1944. A German technical laboratory, far from the front, where the enemy's captured munitions are studied. On a workbench sits an American artillery shell, a dud, one that failed to explode, recovered from a battlefield, and brought here intact, carefully, because a dud shell is a dangerous thing to move. And a German ordnance engineer is about to open it up, expecting to find the ordinary internals of an artillery shell, and about to find something that should not be there at all. If you were that engineer, you knew artillery shells intimately. You knew what was inside one, because the inside of an artillery shell had been essentially the same for a very long time. There was the explosive filler, the bulk of the shell, the thing that did the damage, and there was the fuse, the mechanism in the nose, that told the shell when to explode. And you knew the kinds of fuses there were because there were only a few, and they had been the same for decades. There was the impact fuse, which detonated the shell when it struck something. Simple, mechanical, reliable. And there was the time fuse, which you set before firing to detonate the shell a certain number of seconds later, used for air bursts, requiring careful calculation. These were the fuses. A shell had one or the other, and both were mechanical devices: springs, firing pins, clockwork, the mechanical arts at which German engineering excelled. You expected, opening this American shell, to find a mechanical fuse of some kind, perhaps with some clever features, but fundamentally a mechanical device of a type you understood completely. And so you began to open the fuse, carefully, the way one opens something designed to explode. And what you found inside was not clockwork. It was not springs and firing pins arranged in some clever mechanical sequence. It was electronics. Inside the nose of the shell, where you expected mechanical clockwork, there were tiny electronic components. Miniature vacuum tubes, the fragile glass valves that belonged in a radio set, in a laboratory, in a piece of delicate equipment that lived a gentle life on a bench. Not in the nose of an artillery shell, not in a device fired from a cannon at thousands of times the force of gravity, spinning hundreds of times a second. And yet here they were, miniature tubes, tiny and rugged in a way that should not have been possible, wired into a complete miniature electronic circuit, packed into the nose of a shell. There was, in other words, a radio inside the shell. For a moment, the engineer might simply not have believed his own eyes. It made no sense. A radio was a delicate thing, a laboratory instrument, a piece of furniture in a living room. It was the last thing in the world you would expect to find inside an object whose entire purpose was to be fired from a cannon and to explode. The two categories, the fragile electronic device and the brutal artillery shell, did not belong together, could not belong together, and yet here they were, fused into one, sitting in his hand. It was as though he had cut open a rock and found a clock ticking inside it. And if you were a good engineer, and the Germans were the finest in the world, the questions would have come fast, and each one would have been more disturbing than the last. Why is there a radio in a shell? What does a radio do in the nose of an artillery round? How did they make electronics survive being fired from a gun, when the forces involved should shatter these fragile tubes to powder? And, most disturbing of all, if they can put working, ruggedized, miniature electronics inside a shell and manufacture them by the number required to fire away as artillery, then what is the true scale of the enemy's electronics industry, and what else are they doing with a capability like this? This is not a story about a shell. This is a forensic audit of the moment. A German engineer cut open an American shell and found a radio inside, of the secret weapon that discovery revealed, and of what it told him, in that laboratory, about an enemy whose industrial and technological capabilities were of an order he had not fully grasped until he held the impossible little device in his hand. Part 1. The German Calculus. To understand the shock of finding electronics inside a shell, you have to understand what a fuse was, and had always been, and why the idea of a radio inside a shell was so far outside the German frame of reference, even though German science understood the concept perfectly well. A fuse is the brain of a shell, the part that decides when it explodes. And for the entire history of artillery up to this point, that brain had been mechanical. The impact fuse used the shock of striking a target to drive a firing pin into a detonator. The time fuse used a burning powder train or a clockwork mechanism to count out a set delay before detonating. These were mechanical devices, and they were the products of the mechanical engineering tradition, and the Germans were superb at them. A German time fuse was a little masterpiece of precision mechanics, but mechanical fuses had a fundamental limitation, and it was the limitation that mattered most for the hardest problem in gunnery, which was making a shell explode at exactly the right moment in the air, the airburst. To get an airburst with a time fuse, you had to calculate the exact moment the shell would be over the target at the right height, and set the fuse to that time, and fire, and hope your calculation was right. And it usually was not, quite, because the calculation depended on many variables that could never be known perfectly. Airbursts by time fuse were difficult, wasteful, and unreliable, as we have explored before. What everyone wanted, and what no mechanical fuse could provide, was a fuse that could sense the target itself, that could tell when it was near the target, and detonate at that moment automatically, without any calculation. And German scientists understood this desire perfectly. They understood, in principle, the concept of a proximity fuse, a fuse that detects its own nearness to the target and detonates. The idea was not a secret. It was an obvious goal that scientists in several countries, including Germany, had thought about. So the German engineer opening the American shell was not encountering a concept beyond his imagination. He understood, in theory, what a proximity fuse would be and why it would be valuable. What shocked him was not the idea. It was the realization that the enemy had actually built one, had solved the immense practical problems that stood between the concept and a working, mass-produced device. Problems that were so severe that Germany itself had not solved them. Because those problems were staggering, and the German engineer holding the open fuse would have understood every one of them intimately. To put a radio in a shell, you must miniaturize an entire radio transmitter and receiver into the space of a fuse. You must make it rugged enough to survive being fired from a gun, the instantaneous, brutal acceleration of thousands of times the force of gravity, and the violent spin of the shell in flight, forces that would smash ordinary radio tubes to fragments in an instant. You must include a power source that can survive the same forces and activate at the moment of firing. And then, having solved all of that, you must manufacture the device not once, in a laboratory, but in the enormous quantities that artillery consumes, reliably and cheaply enough to fire away by the thousand. Each of those problems was at the edge of what was possible. And the German engineer, holding the opened American fuse with its impossible little tubes, would have known that Germany had not solved them, that German industry, for all its brilliance, did not have the electronics mass production capability to build ruggedized miniature radios by the number an artillery war required. That is the German calculus, embodied in the engineer at the workbench, a complete understanding of what a proximity fuse was and why it was valuable, combined with the knowledge that building one, miniaturized, ruggedized, and mass-produced, was a problem of staggering difficulty that Germany had not solved and, given its industrial constraints, could not solve. He was not looking at an idea he could not imagine. He was looking at an idea he had imagined and had been unable to build, sitting in his hand, built by the enemy. Now let us look at the device itself and what it did. Part 2. The American Answer. What the German engineer had found in the nose of that shell was the proximity fuse, one of the most secret, most advanced, and most decisive technological achievements of the entire war. A device so valued that its development ranked, in resources and secrecy, just below the atomic bomb itself. Let us explain what he was holding, because the elegance of it is remarkable. The fuse contained a tiny radio transmitter that broadcast a continuous radio signal as the shell flew. When the shell approached a solid object, an aircraft, the ground, a target, some of that radio signal bounced back, reflected off the target, and returned to the fuse. And as the shell got closer to the target, the reflected signal grew stronger. The fuse detected this returning signal, and when it reached a strength indicating the target was within lethal range, it triggered the shell to explode. The shell, in other words, sensed the target itself and chose its own moment to detonate. No timing, No calculation. No skill required beyond aiming in roughly the right direction. The shell did the hard part, the part that had defeated gunners for generations, automatically, in the final fraction of a second, using the little radio in its nose to feel for the target and fire at the perfect instant. And the engineering required to make this work was exactly the staggering achievement the German engineer had recognized. The Americans had developed miniature vacuum tubes rugged enough to survive being fired from a cannon, tubes that could withstand the instantaneous, crushing acceleration and the violent spin without shattering. They had developed a power source that survived the same forces and activated at the moment of firing. They had packed a complete, functioning miniature radio into the nose of a shell and made it work reliably after being subjected to forces that would destroy almost any other piece of electronics. And then, the part that was, in a sense, the greatest achievement of all, they had mass-produced it. It is one thing to build a handful of these in a laboratory. It is another entirely to manufacture them by the tens of millions, on production lines, staffed by ordinary workers, reliably, cheaply enough to fire them away as artillery. The Americans mobilized their vast electronics industry, the companies that made radios and light bulbs and consumer electronics, and turned it to the mass production of these ruggedized miniature radios in a shell, and made them in enormous quantities. That mass production is what turned a brilliant laboratory device into a war-winning weapon, and it is exactly the capability the German engineer knew Germany lacked. And the effect of the proximity fuse, where it was used, was devastating. Against aircraft, it transformed anti-aircraft gunnery, dramatically reducing the number of shells needed to destroy a target, because the shells now found their own moment to explode instead of relying on impossible timing. It proved itself first at sea, making naval anti-aircraft fire vastly more lethal. And later, released for use over land, it produced reliable, murderous airbursts over enemy troops, the shells bursting overhead at the perfect height, defeating the cover of foxholes and earthworks, raining fragments down on positions that should have been safe. The German engineer holding the opened fuse was holding the answer to the hardest problem in gunnery, the automatic airburst, achieved not by calculation, but by a tiny radio that felt for the target and fired itself. He was holding a piece of the future, built by an enemy whose electronics industry could do what Germany's could not. The Germans understood the concept of the proximity fuse perfectly. The Americans built it, ruggedized it, mass-produced it by the tens of millions, and fired it away as ordinary artillery. And that difference, between understanding and building at scale, was the whole war in a single fuse. Part 3. The River of Steel. The radio in the shell connects to the deepest themes of this channel, and the moment of its discovery in that German laboratory is a perfect lens for seeing them, because the proximity fuse is the American way of war, distilled into a single small object. Consider first that it is the purest example of the American pattern of mass-producing precision electronics. We have seen this capability in the universal tank radio, that put a two-way radio in every tank. The proximity fuse is the same capability taken to an extreme, putting a radio in every shell. The common thread is an electronics industry of unmatched scale and sophistication, capable of manufacturing complex electronic devices reliably, in enormous quantities, cheaply enough to distribute them lavishly, in tanks, in shells, wherever they gave an advantage. The German engineer, recognizing the mass production challenge the fuse represented, was recognizing the signature of that industry and understanding that it was of an order Germany could not match. Consider, second, that it embodies the theme of building skill into the device. The proximity fuse took the hardest skill in gunnery, the judgment of exactly when a shell should burst, and moved it out of the human gunner and into the shell itself. This is the same pattern we have traced through the whole American way of war, the interchangeable part that moves skill out of the craftsman and into the tooling, the fire direction system that moves skill out of the individual gunner and into the central calculation, the training system that built competence into the process rather than relying on the rare expert. The proximity fuse is that philosophy in miniature electronics, a tiny automated expert, mass-produced, screwed into the nose of every shell, so that the ordinary gunner no longer needed the rare skill of the perfect airburst. because the shell had the skill built in. Consider, third, the secrecy, which the discovery in the laboratory illuminates. The Americans guarded the proximity fuse ferociously, using it at first only over water, where a dud would sink and could not be recovered, precisely to prevent the enemy from finding one, cutting it open, and discovering the radio inside. Exactly the scene we have been describing. The fact that German engineers did eventually recover and study duds, once the fuse was used over land, was a known risk that the Americans had accepted only when the battlefield advantage was judged worth it. The moment of the German engineer cutting open the shell was the moment the Americans had spent years trying to delay, because they understood that the value of the device depended on the enemy not understanding it, and that once the secret was out, the enemy might develop countermeasures. And consider, finally, the deepest theme, which is that the proximity fuse represents the triumph of the industrial scientific system over individual weapon quality. The fuse was not a better gun or a better shell in any traditional sense. It was a scientific and industrial achievement, the mass production of a miniaturized precision electronic device, bolted onto ordinary artillery. It made ordinary guns and ordinary shells dramatically more effective, not by improving the guns or the shells, but by adding a tiny radio brain that the American scientific industrial system could produce, and the German one could not. It is the clearest possible demonstration that the war was being decided not by the quality of individual weapons, but by the depth of the scientific and industrial systems behind them. The German engineer, holding the opened fuse in his laboratory, was holding all of this, the electronics industry, the philosophy of built-in skill, the guarded secret, the triumph of the system over the weapon, compressed into a device small enough to fit in the nose of a shell. He had cut open an artillery round expecting clockwork, and had found, instead, the whole shape of the war he was losing. Part 4. The German realization. The realization that came to the German engineer, and through him to the German ordnance establishment, was layered and profound, and it went far beyond the single device on the workbench. The immediate realization was tactical and technical. The enemy had a fuse that could produce reliable automatic airbursts and dramatically more effective anti-aircraft fire. And this explained things the Germans had been observing with puzzlement. The increased lethality of American flak, the murderous consistency of American airbursts over their troops. The device on the bench was the answer to those mysteries, and understanding it meant understanding a real and serious battlefield disadvantage. The deeper realization was industrial. The German engineer, understanding exactly how hard it was to build and mass-produce such a device, understood immediately what its existence implied about the enemy's electronics industry. To manufacture ruggedized miniature radios in the quantities that artillery required meant an electronics mass production capability of staggering scale and sophistication, a capability Germany did not possess and could not quickly build. The fuse was not just a weapon, it was a window into the enemy's industrial depth, and what it revealed was sobering. An enemy who could put a radio in every shell was an enemy operating on a different industrial plane. And there was the question of whether Germany could respond, and the answer was grim. Could Germany copy the fuse? German scientists understood the principle, and studying a captured example would teach them much about the implementation. But copying it and mass-producing it were entirely different things, and mass production was exactly what Germany could not do. It lacked the electronics manufacturing base, and its industry was being bombed and starved. Could Germany develop countermeasures, radio jamming to make the fuses detonate early or fail? This was more feasible, and the Germans did work on such possibilities, and the Americans feared exactly this, which was why they had guarded the secret so long. But countermeasures took time and effort, and their own industrial resources, all of which Germany was short of, and by the time the fuse was being encountered on land, the war was already turning decisively against Germany. And there is a bitter irony here, the kind history is full of. The proximity fuse reached the land battlefield in quantity at the very moment the Germans launched their last great offensive in the West, in the winter of 1944. And the murderous airbursts it produced over the attacking German troops, bursting overhead and defeating their cover, were one of the reasons that offensive was met with such devastating artillery fire. So the secret that the German engineer discovered on his workbench may well have already been used against German soldiers in the field in their last great gamble before the Ordnance establishment had fully understood what it was. The discovery in the laboratory was, in a sense, an autopsy, an explanation, arriving too late, of a weapon that had already helped break the final German attack. And the deepest German realization was the familiar one, arriving through the little radio in the shell. They had been beaten, again, not by a concept they could not grasp. They understood the proximity fuse perfectly, but by an enemy who could take a concept they both understood and actually build it, ruggedize it, and mass-produce it, at a scale and with an industrial capability that Germany could not match. The gap was not in understanding. It was in the capacity to turn understanding into millions of manufactured devices. And that gap, revealed so starkly in the impossible little radio inside the shell, was the same gap that ran through the entire war. The gap between a nation that could conceive brilliant things and a nation that could conceive them and then build them by the million and win. The German engineer, closing up his notes on the dissected fuse, understood that he had been looking at more than a clever weapon. He had been looking at the physical proof that the enemy's scientific and industrial system had surpassed his own in a domain, the mass production of precision electronics, that was going to shape not just this war, but the century to come. And he had found that proof and that future packed into the nose of an ordinary shell, where he had expected to find nothing but clockwork. If your father, your grandfather, or your uncle worked on the proximity fuse, one of the scientists, engineers, or the countless workers who built those impossible little radios by the million, most of them never told what they were making because the secrecy was total, or if he was an artilleryman or anti-aircraft gunner who fired them, I would be grateful to hear his name in the comments. The proximity fuse was built largely by people who were never allowed to know what their careful work would do, and it was one of the war's decisive weapons. They are mostly gone now. What remains are the stories their families carry. Those stories belong in the record. Part 5. The Verdict. 1945. The war ends, the secret of the proximity fuse comes fully into the open, and it takes its place in history as one of the handful of technologies that genuinely changed the war, ranked by senior figures among the most important scientific achievements of the entire conflict. So here's the verdict. The German engineer cut open an American shell expecting to find clockwork, the mechanical fuse that had been the brain of artillery for as long as artillery had existed. And he found instead a radio, a miniature, ruggedized, mass-produced electronic device, packed into the nose of an ordinary shell that could sense its own approach to a target and detonate at the perfect instant. He understood immediately what it was, because German science understood the concept of the proximity fuse perfectly well. What he understood with equal force was that Germany had not built it and could not build it, because building it required an electronics mass production capability that Germany did not possess, the capability to manufacture ruggedized miniature radios by the tens of millions and fire them away as ordinary artillery. The German engineer who found the radio inside the shell was, in that laboratory, making the discovery that his whole nation was making across the whole war. He was holding a concept both sides understood, built by the side that could build it, and he was recognizing, in the impossible little device, the industrial and scientific gap that was deciding everything. The Germans could conceive the proximity fuse. Only the Americans could fill the sky and the battlefield with it. The Germans understood the idea of a radio in a shell. The Americans put a radio in every shell, millions of them. And the difference between understanding the idea and building it by the million was, in the end, the difference between the nation that lost and the nation that won. The German engineer went looking, inside an American shell, for the clockwork of the past. And he found, instead, the electronics of the future, mass-produced, ruggedized, and fired away by the thousand, by an enemy whose true advantage was never any single weapon, but the scientific and industrial power to build the future faster than anyone else could even imagine it. If this forensic audit gave you something to think about, hit the like button. It keeps this channel visible to the people who want the history the way it actually happened. Subscribe if you want the next audit, because there are more of these, more systems, more decisions. More of the invisible, unglamorous machinery that decided who won and who came home. And remember this about the radio in the shell. Nobody makes a film about a fuse, the small device in the nose of a shell that decides when it explodes. It is the least glamorous component of the least glamorous weapon. And yet inside that humble device, the Americans placed one of the great secrets of the war. A tiny radio, rugged enough to be fired from a cannon, that felt for its target and chose its own moment to die. The German engineer who cut one open found, where he expected clockwork, the future, and understood, holding it, that he was losing to an enemy who could not only imagine such things, but build them by the million, and fire them away without a second thought. Mostly, when an American shell needed to burst at exactly the right moment, the little radio in its nose felt for the target and fired itself. A tiny automated genius, mass-produced, expendable, and utterly beyond what the enemy could match. They deserve to be remembered. The scientists, the engineers, and the unnamed workers who built a miracle they were not allowed to understand, by the strange truth that some of the most decisive genius of the war was packed into the nose of an ordinary shell, and that the enemy discovered it only by cutting one open and finding, where clockwork should have been, a radio and the shape of a future he could not match.